To match the graph with the function, you should recognize that all the answer choices are in vertex form, so we should find the vertex of the parabola. It is at 5, 1, 5 over, 1 up, and when you put that into vertex form, you always flip the sign on x, and it goes inside the parenthesis, and you keep the sign on y. The next thing we'll notice is that parabola opens down, so we need a negative in front of the parentheses. So actually the only option with a negative sign out front is A, and there's the minus 5, and there's the plus 1. To find the complex conjugate, all you have to do is flip the sign in front of the imaginary part of the I. So we have negative 9i, we just need to flip it to positive 9i, so that'd be choice A. Number 3 is the same thing. We need to flip the sign in front of the imaginary part. So 5i is the imaginary part. We don't want it to be negative 5i. We're going to look for positive 5i, and we leave the sign on the real part the same. Don't mess with the sign on the negative 3. To write our final answer, we need to flip-flop those so that the real part's first, the negative 3 is first, and then the plus 5i is second. So that would match up with answer C. For number 4, I'm going to label A, B, and C. A is 2, B is negative 4, and C is 5. To figure out if something opens up or down, it depends if A is positive or negative. If A is positive, it opens up. If it's negative, it opens down. And A is positive 2, so this parabola opens up. For the axis of symmetry, we need to use that formula, negative b, so it's going to be negative negative 4, divided by 2 times a, which is 2. So on top, negative negative becomes positive 4. On bottom, 2 times 2 is 4, and 4 over 4 equals positive 1. So the axis of symmetry is x equals 1. We're going to take that and use it to figure out the vertex. So we already know the vertex is 1 over, so we just have to figure out how high it is up. So we're going to figure out f of 1, because we just figured out x equals 1. So into the formula, and I'll make the 1 blue so it stands out. We have 2 from the formula, and then for x, we're going to plug in the 1 inside parentheses and square it. Next we have minus 4, and then in parentheses we will plug in our number for x, which is 1, and then finally plus 5. So first you square the 1. 1 squared is 1, so 2 times 1 is 2. So this is going to be 2. Negative 4 times 1 is negative 4. So 2 minus 4 is negative 2, and negative 2 plus 5 is 3. So our vertex is 3 units up. So the x was 1, the y is 3, the vertex is 1, 3. The y-intercept is whatever c is, and c is positive 5, so our y-intercept is 5. So let's put all this info on the graph. We need to put a dashed vertical line through x equals 1. We need to plot the vertex, which was up 3 units. We can put on the y-intercept through 5, and I will put the mirror image of that point on the other side of the axis of symmetry. And now you can connect those dots with the parabola that opens up. Now that we have the graph drawn, we can see that since this opens up, it has a minimum, it has a low point, it never goes below 3 right there. So the minimum, it goes all the way down to 3, but never any lower, so y equals 3 is the minimum. The domain for parabolas that open up or down is always all reals, so you can write all reals, or all the x's such that x is an element of the reals. And the range is the set of all y's such that y is, and our parabola is all above 3. So we need to put a greater than or equal to 3 for the range. Everybody should get number 5 right. I just need where this parabola crosses the x-axis, and it goes through 3 and 5. For number 6, I recommend factoring because everything's on one side of the equal sign, and we can find the factors of 50 that add up to positive 15. The factors of 50 would be 5 times 10. So 5 plus 10 is 15. So we'll put x plus 5 and x plus 10. Those are the factors. We need the zeros. All right, inside parentheses, those are factors. To get the zeros, you set them each equal to 0, which means that the signs flip, and one of the zeros is at negative 5, and the other 0 is at negative 10. You don't have to graph it, but it means your parabola goes through right here and right here. That's what it means. I'll do number 7 by foiling. Oops, so first we have to multiply the first items in the parentheses. So x times x is x squared. Now for the outside, x times negative 5 is negative 5x. Now for the inside, 6 times x is 6x. And the last terms, positive 6 times negative 5 is negative 30. Next step is to combine your like terms and write your final answer. So negative 5 plus 6 is positive 1, or just plus x, and then minus 30. I'll do number 8 by the box method. So I'm going to draw a box that's 2 by 2. I'll put 2x and positive 3 on the side, and I'll put x and negative 4 on the top. Now we go through and multiply. 2x times x is 2x squared. 3 times x is 3x. 2x times negative 4 is negative 8x, and 3 times negative 4 is negative 12. So then we combine our like terms and write the final answer. 2x squared, 3 minus 8 is negative 5x's, and then the minus 12. A graph with no real zeros has imaginary zeros. So that's the kind of parabola that floats either above the x-axis opening up or below the x-axis opening down. Make sure you also know how to draw a graph with 1 real zero and 2 real zeros. When we have vertex form and we want to describe the transformation, inside the parentheses next to the x is always a left-right move, and it's the opposite. And outside the parentheses is always a vertical move, true to sign. So a plus 3, you would normally think it means to the right, but it means to the left. So this would be a vertex that moves left 3 units, and since there's a minus 4 on the outside, it means that it moves down 4 units. It might help you to just flip the sign on the 3 and then keep the sign on the 4. And since that's where the vertex is, then you can say left and down. On number 11, that's all you have to do. You have to name the vertex. So remember, you flip the sign inside and you keep the sign outside. So this vertex is at negative 2, negative 10. We are going to factor this because that's what I recommend. Everything is on one side of the equal sign. So we are going to look for factors of 10 that subtract to give us 3. So 2 and 5 will do the trick. We need to have the 5 positive and the 2 negative, so that 5 minus 2 is positive 3. So I'll put a plus 5 and a minus 2 inside the parentheses. Those are the factors. We need the zeros. So you set them equal to 0 and solve. In other words, you flip the signs. So one 0 goes through negative 5, the other goes through positive 2. My hint for you on this type of a problem is always to look for a GCF. What can you divide both of those by? It is all set equal to 0. So the GCF for all of these problems where a ball is being kicked or hit off the ground, the GCF is negative 16t. So we divide by the GCF, write it out front, and write the leftovers next to it. So all of that cancels out except for 1t. 256 divided by negative 16 is negative 16, and those t's cancel out. So that all equals 0. Now we'll set each factor equal to 0. So negative 16t equals 0. And we'll set that factor equal to 0. When you solve, you get t equals 0. So when the time is 0, that's when the ball leaves the ground. And the other factor is positive 16. So that means, and you'll have to extend the graph a little bit out to 16, that the football leaves the ground and then it comes back down to the ground after 16 seconds. So how many seconds will the football be in the air before it hits the ground again? Your final answer here is 16 seconds. My recommendation on 14 is to complete the square. Everything is on one side of the equal sign. You could try to factor it, but you're not going to find factors of 8 that subtract to give you 14. So we're going to proceed with completing the square. The first thing we have to do is get c on the other side. So I'll move the 8 over, and I'll have x squared plus 14x. I'll leave a space for the perfect square. 8 will be on the other side, and I will add a space for the perfect square. So what goes inside the square? You take b divided by 2 and square it. So 14 divided by 2 is 7, and 7 squared is 49. So that's what you add on both sides. Next, we're going to factor the left side. So everything I just underlined in blue, we are going to factor. And it's a perfect square. We just created it. So what factors of 49 add up to 14? X plus 7 and x plus 7. So x plus 7, quantity squared, is on the left, and 8 plus 49 is 57. The next step is to square root both sides to get rid of the 2, and you're left with x plus 7 equals, don't forget the plus or minus sign, plus or minus square root 57. You can try to factor tree 57, but you just get 3 and 13 as factors. So you need to get x by itself by minusing 7 from both sides. And now we have our final answer. We will write the real part first, so put the negative 7 first, and then put plus or minus the square root of 57 after it. That's the final answer. Number 15, I also recommend completing the square. And in this one, we already have c on the other side. So I'm just going to scooch everything over so that I have a little more room here. X squared minus 6x, and now we need to add a perfect square on the left. We already have the 40 over there, but we need to add the perfect square on the right. So what are we going to add? 6 over 2 is 3, and 3 squared is 9. So we're going to add 9 on both sides. So now we need to factor everything on the left. Factor all that. It's going to factor into x, and the factors in 9 that add up to negative 6 would be negative 3. 40 plus 9 is 49. Now we need to square root both sides. So we have x minus 3 equals, the square root of 49, we know that, it's plus or minus 7. Next, we add 3 to get x all by itself, and we're going to have 2 answers. One of the answers comes from positive 7 plus 3. That's 10. The other answer comes from negative 7 plus 3. Negative 7 plus 3 is negative 4. To solve for x and y, I notice x is a real number on the left, and 20 is a real number on the right. So let's set those equal to each other and solve. When we do that, we get x equals 5. Now let's set the imaginary parts equal to each other. So negative 6i equals negative 18yi. First thing, cancel out those i's. And the y's multiplied by negative 18, so we need to divide both sides by negative 18. And when we reduce, negative becomes positive, and 6 over 18 reduces to 1/3. Same procedure on number 17. 5x is real on the left, 50 is real on the right. So 5x equals 50, which means x equals 10. Now the imaginary parts get set equal. Negative 8i equals negative 16yi. So we'll cancel out the i's, divide both sides by negative 16, and y is positive 1/2. To complete the square, you take b, divide it by 2, and square it. So 20 divided by 2 is 10, and 10 squared is 100. In number 19, we take negative 22 and divide it by 2. That's negative 11, and negative 11 squared is 121. Notice in number 20, I don't really recommend anything as far as factoring or completing the square or anything like that, or quadratic formula. You could try to do all those, that's fine. I'm just going to go through and try to get x all by itself. Not x squared, but just x all alone. So first I'll get rid of the 50 to the other side. So 5x squared equals negative 50. Next I need to get rid of the 5. I will do that by dividing. So x squared equals negative 10. Last thing is to square root both sides, and x will equal plus or minus. Now I can't reduce the square to 10 because if I factor tree it, I'm only going to get 2 and 5 for factors. But that negative sign underneath it becomes an I. So we put the I in front of the square root sign, and the 10 stays underneath. Same thing on number 21. Let's get x all alone. I'll move the 16 over first. So x squared equals negative 16. X equals plus or minus. Now I do know the square root of 16. The answer to the square root of positive 16 is 4. What happens to that negative sign? It becomes an I. Now I recommend the quadratic formula. You can't find factors of 10 that add up to 1. And we're not going to complete the square on this because we already practiced completing the square. So I'm going to label A, B, and C. And it's okay that A and B are both 1. See how I filled in those 1s? It's perfectly fine. So the formula is negative B, so negative 1, plus or minus the square root of B squared, so 1 squared, minus 4 times A times C. So A is 1 and C is 10, all divided by 2 times A, which is 1. So let's take everything underneath and simplify it. 1 squared is 1. Negative 4 times 1 is negative 4, and negative 4 times 10 is negative 40. 1 minus 40 is negative 39. So that's what's underneath the square root sign. So out front I have a negative 1 plus or minus the square root of negative 39. Underneath I have 2. So we're going to see if we can simplify the square root of 39. 39 we have 3 and 13 going into that. So no factor pairs come out. So that'll stay, but we can deal with that negative sign. So I'm going to take the negative 1 over 2, and that doesn't reduce. Then I'll put the plus or minus sign. I know that negative turns into an I, and the I has to be in front of the square root sign. The 39 stays, and the 2, really there's a 1 right here, so that doesn't simplify either. So that's your final answer. Here's another quadratic formula example. A is 1, B is 3, and C is also 3. So into the formula goes negative 3 plus or minus the square root of B squared, so 3 squared, minus 4 times A times C, so 1 and 3, all divided by 2 times A, which is 1. So it's simplified time. Everything underneath. 3 squared is 9. Negative 4 times 1 is negative 4. Negative 4 times 3 is negative 12. 9 minus 12 is negative 3. So that's what goes underneath the square root sign. Out in front, you have a negative 3 and a plus or minus sign. Underneath the square root sign, we have negative 3. And on bottom, 2 times 1 is 2. So we need to see if we can simplify the square root of 3. And of course, you can't simplify the square root of 3. So the last step is to see if we can simplify any of the numbers on top and bottom. Negative 3 over 2 does not simplify. We have a plus or minus sign. The only thing we can do is take care of that negative sign. It's going to become an I out in front, while the 3 stays underneath the square root sign. If there was a number in front, it'd be a 1, but you can't simplify 1 over 2. So the 2 on bottom stays, and that's your final answer. To find the number of zeros, we need to use the discriminant. That is the formula b squared minus 4ac. So we need a, b, and c. Everything is on one side, so a equals 2, b equals negative 16, and c equals 32. So the discriminant will be b squared, so negative 16 squared, minus 4 times a, which is 2, and c, which is, 32. So we need to square negative 16. That will be positive 256. Negative 4 times 2 is negative 8, and negative 8 times 32 is negative 256. So what ends up happening here is 256 minus 256 equals 0. And when you have a discriminant equaling 0, that tells us that we're going to have one real 0. If you get a positive number for the discriminant, it means you have 2 real zeros. If you get a 0, it means you have 1 real 0. And if you get a negative number, it means that you have 2 imaginary zeros. So there's a table with that on the back of your 5-6 notes. But when you get 0 for the discriminant, it means you just have the kind of parabola that looks like this. Same thing on number 25, although it looks sort of crazy. I'm going to move this f of x because our equation has the negative 12 on the wrong side. So we need to add 12 to the same side as everything else. So it's x squared plus 5x plus 12. Now we can write down what a, b, and c are. So a is 1, b is 5, and c is 12. So they go in the discriminant formula. B squared, so it'll be 5 squared, minus 4 times A times C. And we're going to get 25. Negative 4 times 1 is negative 4, and negative 4 times 12 is negative 48. So 25 minus 48 is negative 23. So since we get a negative number for the discriminant, it means that we have two imaginary zeros. So this is the kind of parabola that's floating either above or below the x-axis.